Have you ever wondered how your car knows exactly how much fuel to inject into the engine? The answer is a small but incredibly important component called the oxygen sensor, or O2 sensor. In this video, I'll explain exactly how oxygen sensors work, how they communicate with your vehicle's engine control unit, ECU, why modern cars use multiple sensors, and what happens when one fails. Let's get started. The oxygen sensor is mounted in your vehicle's exhaust system, where it measures the amount of oxygen remaining in the exhaust gases after combustion. Its job is simple, but extremely important. Instead of measuring fuel directly, the O2 sensor measures unused oxygen. The ECU then uses this information to determine whether the engine is running rich or lean. A rich mixture means there's too much fuel and not enough air. A lean mixture means there's too much air and not enough fuel. For gasoline engines, the ideal air-to-fuel ratio is approximately 14.7 parts air to 1 part fuel. This is known as the stoichiometric ratio, where the catalytic converter works most efficiently and emissions are at their lowest. Here's how the communication works. As exhaust gases pass over the oxygen sensor, the sensor generates a voltage. A traditional zirconia oxygen sensor produces anywhere from about 0.1 volts to 0.9 volts. If the engine is running lean, there's more oxygen in the exhaust, and the sensor outputs a low voltage, around 0.1 volts. If the engine is running rich, there's less oxygen in the exhaust, and the sensor outputs a higher voltage, close to 0.9 volts. The ECU constantly monitors this changing voltage. If it detects a lean condition, it increases fuel injector pulse width to add more fuel. If it detects a rich condition, it shortens injector pulse width to reduce fuel. This adjustment happens several times every second while you're driving. This constant correction is called closed-loop operation, allowing the engine to maintain peak fuel economy, better performance, and lower emissions. Most modern vehicles have at least 2 oxygen sensors. The upstream sensor, located before the catalytic converter, is the primary sensor used for fuel control. The downstream sensor, located after the catalytic converter, mainly monitors catalytic converter efficiency. The ECU compares readings from both sensors. If both sensors produce similar signals, it may determine that the catalytic converter is no longer cleaning the exhaust properly, triggering a check engine light with codes such as P0420 or P0430. Modern vehicles may also use wideband air-fuel ratio sensors, which provide much more precise information than traditional narrowband oxygen sensors. This allows the ECU to make even finer fuel adjustments for improved efficiency and lower emissions. When an oxygen sensor fails, symptoms can include poor fuel economy, rough idle engine hesitation, increased emissions, loss of power, a check engine light. Ignoring a faulty O2 sensor can eventually damage the catalytic converter, which is one of the most expensive emissions components to replace. Now you know how oxygen sensors work together with your car's ECU to constantly adjust the air-fuel mixture for maximum performance, fuel economy, and reduced emissions. If you found this video helpful, give it a thumbs up, subscribe for more easy-to-understand automotive repair videos, and leave a comment below with any automotive topic you'd like me to cover next. Thanks for watching, and I'll see you in the next video.